Hey, physical science students, Miss Crowley here. So, if you come to class, this is what we do live, where we go over the notes and then we fill in the guided notes together. But if you didn't come to class, then you were supposed to watch this and then fill in the notes on your own. So, I think it works best if you can split your screen. So you have this on one side of your screen, and then you go to Schoology, upload your PDF to Notability, and then you're able to write on it. And if you then swipe up on your screen, you can take Notability and then bring it all the way to the right until you see that your screen is split. So you have this video going and the PDF in Notability, so we can write in it together. All right, so we are starting our new unit about matter. So we just finished up the metric measurement unit and the observation and inference unit about qualitative and quantitative. So now we're going to learn about matter. So what is matter, right? So matter is all stuff. Everything is made up of matter. And the smallest form of matter is called an atom. So now that you see that is a bolded, or not bolded, but capitalized and underlined, you know that atom is going to go in your guided notes. So the smallest form of matter is called an atom. And then when two or more atoms are bound together, we call it a molecule. So they can be two of the same things, like they could be two hydrogen atoms, and it would be H2, because there was two of them. Or it can be different atoms. The one you probably know about is H2O. So that's a way of writing water. So H2O is two hydrogens, because it's H and then a 2. So two hydrogens, and then the O stands for oxygen. So it's one oxygen with two hydrogens. And so there's three atoms that are bound together in what we call a molecule. Okay. So the other part you put in your guided notes is when two or more. So molecules are formed when two or more atoms are bound together. So when we describe this, we're just going to call them particles. So we're not going to distinguish between atom and molecules. We're just going to talk about particles and how the particles move in matter. Okay, and what makes the particles move faster and what makes them move slower. So when we refer to matter, we call the atoms and the molecules particles. So if you could write particles in your sheet, it's PARTICLES. So particles. And now there's three states of matter, and I bet you already knew this from 5th grade, but we review it. They're solid, liquid, and gas. There is actually a phase called plasma, but in science class this year, we're just going to talk about solid, liquids, and gases. So solids, SOLID, liquid, LIQUID, and gas, GAS. Those are the three phases of matter: solid, liquid, and gas. Okay, so what makes them change state is how much heat energy they have. We also call this thermal energy. So by heating or cooling, the amount of heat energy a substance has changes, and that's going to make it change state. Like something you probably know about is ice. Ice is a solid. When you heat up ice, it turns into liquid water. And when you heat up liquid water, like boiling it, it turns into a gas. So in that case, you keep adding more heat energy. So you take the ice, you heat it up, add more heat to it, it becomes a liquid, add even more heat to it, becomes a gas, or sometimes we call that water vapor. Now, you can go the other direction. So a gas can turn into a liquid. So for example, condensation is what it's called. It's on a really hot day and you have a cold glass of water and you put it on the table and then you pick up the glass and there's a ring on the table. That's condensation, because what happened is the gas that's in the air was cooled near the cup, and it cooled enough to change it to a liquid, and then that liquid sticks to the glass, and then it goes down onto your table. So that's why we use coasters in the summer. So you can make something go from a gas to a liquid, so water vapor, back to liquid water. And then you all know about freezing because we live here in Minnesota, right? So we know that. So we know that when it gets below 30 degrees, about below 32 degrees, the liquid water is going to freeze. And also is a point that it melts. 32 degrees is the melting point and the freezing point of water. And in Celsius, the freezing is 0 and the boiling is 100. Okay, so adding heat energy is going to make it change state, and then taking away heat energy is going to make it change state because the molecules slow down. Okay, so now what we have to do is we have to know matter with solids, the properties of these different phases. So solids have a definite shape. It has a definite shape and a definite volume. So for example, what do I have? What do I have here? I have my AirPod case, right? This is a solid. So this is a solid. It has a shape and it has a definite volume. I could measure the length, the width, and the height and get the volume, and it keeps its shape. And that's because the particles are really close together. They're in a fixed position, like in the picture where you see the particle arrangement. They're in a fixed position, but that does not mean that they're not moving. They are. They can vibrate. So all of the particles are always going to be moving. Okay, so a solid, let's go over this again so you can write it in your sheet. So a solid have a definite shape and a definite volume. And the particles are very close together. And the particles are fixed in place, but they can vibrate. So shape and volume. The particles are very close together, so write very close. And the particles are fixed in place, but they can vibrate. And now we get to liquids. So liquids have a definite volume. They take up a definite amount of space, right? So if you pour your water into a cup, it takes up a certain amount of space in that cup, but it doesn't have any shape. So then if you spill your water, right, it's all over the floor and it has no shape. So liquids have a definite volume. They take up a definite amount of space. We can measure it. Remember, we learned about measuring. We can measure it in a graduated cylinder. But they do not have a specific shape. So no shape is what you write in for liquids. The particles are close together, not as close as in a solid, but they are close together. And they can flow. That's why you can pour a liquid, right? Because the molecules can flow over each other and move past one another. So the particles can flow. So no shape, close, and then flow are the words that go in the blanks. So the particles can easily flow and move past one another. All right, to gases, they have no shape and no volume, right? So if you blow up a balloon and then you pop it, all the gas that's in the balloon is just going to spread out and take the shape of the next container, like the room, right? So it's going to move. So gases do not have a specific shape, nor do they have a specific volume. So you would write no and then definite shape or volume. Okay, the particles are far apart, so far apart, right? Compared to a liquid. And look at the picture where it says particle arrangement, and they move freely in any direction. So they can move freely. They also have the most energy. Remember, like you see the water vapor, it has the most energy compared to the other states of matter. And not everything on Earth can have be a solid, a liquid, and gas. Water is one of those things that is. It's a solid, it's a liquid, and a gas all in nature. But we have something which is one of my favorite, is what we call dry ice, right? So dry ice does not have a liquid phase. That's why it's called dry, because there's no liquid phase. It goes directly from a solid to a gas. It has no liquid phase. Okay, so not everything on Earth has both a solid, a liquid, and a gas phase. And I think that is it. So those are our notes for this unit about matter, about solids, liquid, and gases. And solids have a definite shape and a definite volume. Liquids have a definite volume, but not a definite shape. And gases have no shape or no volume. And the state that they're in depends on the amount of heat energy they have, because the particles move faster when they have more energy. And if they move faster, they move farther apart from each other, and then they change state. So, all right, I hope you enjoyed this, and I will see you this week, hopefully at a Google Meet. Bye.